second question, we've got slightly more interesting shapes than cuboids, and this is where I really like to draw out the nets, because it does mean that we've got a real visualization. Because before we knew that our top and the bottom were the same, front and the back were the same, left and the right were the same. Not so here. So we've got a triangular prism. Now I'm going to do this one slightly different. I'm still going to make this one the front. I'm going to draw my front over this side. Oh, there we go. So my front. Okay. And it's connected. The reason I've done this is so I've got the right angle here. It's really important, to the back. Okay. By the height. Okay, so that's this one here. So I'm just going to call this one. I'm going to call this one here face 1. Okay, so this is face 1. Then I'm going to think about unwrapping the front of this. So I've turned it around and unwrapping this towards me. So if this is the back, this is the bottom. And finally, this bit here is going to flip out down the bottom and be face 3. Okay. If I were in class, I would show you, using my magic unfolding shapes, how this works. Unfortunately, I can't. Hopefully we'll get a chance to go through it in class another time. So, my back and my front are the same because it's a prism, and that means the back and the front have to be the same. Cross section must be the same all the way through. So I only have to calculate one of them. So let's calculate the front. So it's a triangle, so it's base times height divided by 2. The base is 7.5 times by the height, 10, divided by 2. That's 775 divided by 2. 37.5. Okay. Remember, the back is exactly the same. Now we're going to think about the surface here, the one that we can't see. It's behind the shape. Now, this shape is a rectangle, and it's got height 10, because the height of the triangle is 10. And it is 12 centimetres long. Okay, so for for rectangle number 1, I'm going to do 10 times 12. Nice and easy, 120. We've only got one of them, so don't try and double it. Now for rectangle number 2, okay, so that's the rectangle that it's sitting on. I've got 7.5, which is the same as this, isn't it? This is 7.5. If you think about it, if we folded this shape up, 7.5 would match it with that there, 7.5. And we can already see from our diagram, this rectangle is 12 along, and indeed it is. So we've got 7.5 times 12. times 12 is 90. Again, we've only got one of those. Finally, rectangle 3. Luckily they've given us the slanting edge of the triangle, which is 12.5. Now think about it, if we're rolling our triangle, that'd be the 10, that'd be the 7, which means this one must be the 12.5, and we already know that it's 12 wide. So that one's going to be 12.5 times 12. 12.5 times 12 is 150. We then add all of those together to get my surface area. So I've got 37.5 I've got 37.5 120, 90, and I've got 150. And I've got no room to actually work out my answer. Well done, Mrs. Ward. Oh, I'm an idiot. 5 out of 5 is 10. 1/8 15, 1 4 7 9 18 23, 435.0. Okay. Now the other side is a cylinder. Again, I really wish I had my unfolded shapes, because I could show you that when we unwrap a cylinder, it is actually this shape. Now, if you've ever taken the label off a tin of beans, or indeed a bottle of drink, you'll think, actually, yes, that makes sense. It is a rectangle that wraps around a cylinder. And the reason for that is because a circle has only got one edge, so it only needs one face to wrap around. Now, if we think about the circles, we know how to find the area of a circle. We did that just before Easter. That's if you're one of my year 10s watching this on lockdown. So the area of the circle, which of course will be the front and the back, is pi times the radius squared. So pi times, well, the diameter is where did I get 7 from? Is 9 centimetres, which means that the radius is going to be 4.5. Pi times 4.5 squared. I pop that into my calculator. Which gives me 81/4 pi, or 63.62. You'll notice, even though it says 1 decimal place, I am using 2 decimal places because I'm not at my answer yet. The back is going to be exactly the same, 63.62. And then we've got this rectangle. Now we know that this rectangle is 12 long. There's 12 centimetres in between the front and the back, or the top and the bottom. You could call them front and back, or top and bottom. Depends on whether your cylinder's rolling around or stood on one end. But what about this? The height of my rectangle. Well, this has got to wrap all the way around my circle, which means that that's got to be the circumference of my circle. So before I do anything else, I need to find my circumference. Now, hopefully remember that circumference equals pi times diameter. Pi times the diameter is 9. Now, when I put that into my calculator, it also helpfully tells me that pi times 9 is 9 pi. I'm pretty sure you can figure out that all on your own. We want it as a decimal, 28.27. Remember what I said? Make sure you leave 2 decimal places. Now that is not an area. That is a circumference. That is a line. That is the orange line that I've just drawn very badly around the edge of the circle. And that is this bit here, which is 28.27. So if we find the area of the wraparound rectangle, we're going to do 12 times 28.27. I'm not going to do that one in my head. Which gives me 108 pi, even less useful, 339.29. What I do now is I add up the front, the back, and the rectangle. I do not add on the circumference. So I'm going to use my calculator for this one. So I've got my answer here. I'm adding on 63.62. I'm adding on again 63.62. And that gives me an answer of 466.53. But remember, we only want our answer to 1 decimal place, and so it's going to be 466.3.